Okay, let's see how you did on describing the distribution. So, can you identify all those conditions and assumptions that we must have so that we have this normal model distribution that we can do the math with? So, here we go. So, this first one is a proportion problem. Again, you're noticing that if you've got these percentages and you aren't given a mean or a standard deviation, then it's probably a proportion problem. All right, so here's how I got my shape. I did random. So it was stated that we had randomly selected 300 children. So I went that stated or assumed is what you're putting there. And then you're saying that there were 300 randomly selected children. So you're kind of identifying what the sample is. Next, you're independent. N is less than 10% of the population. So here I'm saying 300 is less than 10%, and you're identifying specifically what the population is of all American children. Large enough is tricky because it all depends, mean or proportion. So this is a proportion problem. Mean is 30, but proportions is at least 10 successes and at least 10 failures. So the way that looks is N times P, and the population P was 0.28, okay? So NP, and you say how much that is greater than or equal to 10. N times 1 minus P, and you say how much that is greater than or equal to 10. So the normal model applies now approximately. So I'm going to put that into the song where the goat's supposed to go, and the normal model applies now approximately. Make sure you put that in there. So there's our shape, our center. So really what you could just do is put that mu of p hats equals 0.28. So really you didn't even have to write out what I put in words. You could just say the mu of your p hats equals 0.28. Okay, and the spread, the standard deviation of the p hats, and then show the computing, the square root, so which show this part here equals 0.26. Okay. All right. Next, then we've got this one was a mean problem. So here we go. Shape, random. It was stated that they were randomly selected 36 seniors. So I identified the sample, stated as or assumed, and randomly selected. Independent. So I'm assuming I wasn't sure if this was going to be right. So I'm not sure if 36 is less than 10% of all Northside High seniors. So now I could say it's less than 10% of all students taking the exam. What's the population? See, I think kind of our population is the Northside seniors. I think we're trying to make a claim about that, the Northside seniors. Large enough is means, so we just have to say 36 is greater than or equal to 30. So approximately normal model applies. The mean of the sample means is 18.6. And then the standard deviation of the sample means, you could show this. So this you can write there. Okay. All right. Third one is a mean problem as well. So we had randomly stated that they were randomly selected 10 steel bars. Interesting. 10 is a small sample size. So that's something that alerts me that, I'm concerned, got a small sample. So we'll talk about that as we get into this further. Then we had independent. 10 is less than 10% of all such steel bars cut by this machine. Large enough is tricky. 10 is not greater than or equal to 30, okay? But remember that if the sample size is not large enough, there's still hope. If it was stated that the population is approximately normal, and it did. It said up here that the distribution of the cuts are approximately normal. Then we're covered. then we can say, okay, approximately normal model applies. All right, the center is this here. So you can just write this, the mean of the x bars. And then for the spread, the standard deviation of the x bars, and show the work to how you get that. All right, next. So here we've got, this one was a proportion problem. So what we're going to do then is for our random, it was stated that we had randomly selected 72 jurors. Independent, 72 is less than 10% of all Parker County jurors. That's the population that this is about. So do you see that in those conditions, I'm identifying what the sample is, and I'm identifying what the population is. So that's something that you're keeping in mind, and this is something that you're indicating to the reader or the grader or whoever is looking at your research, that you're identifying what those things are. Large enough is tricky because let's see what's going on here. So it's a proportion problem. So I need to do n times p, so 72 times 0.13. And that is not greater than or equal to 10. So yikesies. Okay, let's look at the next one. 72 times the 1 minus p. So that one is greater than or equal to 10. So what I wrote is this. I'm concerned that the sample size is not quite large enough. So I'm not sure that the approximately normal model applies, but it is close. Okay? So see, it's okay. You would then continue the problem. You pretty much don't ever stop unless it leads you down that path. Here, it's close, but so I'm acknowledging that I'm concerned, but then I'm going to continue. Okay, the center, the mean of the p hats is 0.13, and the standard deviation of the p hats is computed this way and is 0.04. All right. The next one is another proportion problem about the fatally injured drivers being intoxicated or not. So randomly selected, was it stated? I should have said that. Yep. Well, does it say based on the random sample? No, it just says based on the sample. So you know what I should have put in here then, I guess, is the word assumed. So I should have put assumed that it's randomly selected 60 unless, oh, nope, there it is. It's stated. Okay, so then I should have put stated. Okay, so it's stated that it was randomly selected. Okay, cool. So I'm stating or assuming. And then here I go. I'm assuming because I don't know. I don't know the number. So I'm assuming 65 is less than 10% of all. And here I am defining the population, all Dallas County driver fatalities. Large enough is proportion. N times P. P was 0.77, and that's 50. And N times 1 minus P was 14.95. So both greater than or equal to 10. Approximately normal model applies. The center, of course, is your mean of the p hats right here. You can just write that in symbols. You don't have to put the words. And your standard deviation of the p hats. Write that there. Okie dokie. Next, it's a mean problem. We're talking about the rainfall. 48 months are not stated to be randomly selected. So that's, what am I doing? I don't know. So I'm going to put this. I'm assuming them to be representative of all current months in terms of the rainfall. So that's the best I can do. I'm not an expert or weather expert, so I don't know. So upon somebody being able to confirm that they're representative, then we're good to go. Okay? Independent, 48 is less than 10% of all months of rainfall. Yes, it is. Large enough, it is large enough, greater than or equal to 30, so approximately normal model applies. Our center is the mean of the x bars, and the standard deviation of the x bars computes to be that 0.35 over the square root of 48. Okay, I think that's all your conditions. So random, independent, large enough, and if you have some of those little concerns, that's fine. You're noting that, and then you're continuing. Okay, so I hope that that makes sense on how you verify that your approximately normal model applies.